Myself, Kiranmai, I am working as assistant professor in BVRIT Narsapur College in data science department. Today I am going to teach you a topic in computer organization subject where we are going to be discussing about input-output organization. In that I am going to be discussing about input-output interface. When we go with input-output interface, actually it provides a means for transferring the data between the internal storage and the external I/O devices. CPU needs to communicate with the internal memory and it should communicate with the I/O devices. But here there lies and differences between the processor and the I/O devices. In order to remove those differences, we are going to be having a separate interface module between the processor and the different I/O devices. So this particular internal interface, what we are going to using, that is going to be providing a special communication links for interfacing the processor and the I/O devices. In order to resolve the differences, we are going to be including interface between processor and each I/O device there. So here, let us go with discussion of what are the different differences that lie between the processor and the I/O devices. The different differences there are, when we go with the differences, there are like 4 major differences between the processor and the I/O devices or the peripherals. What are those? Are like, when we take the peripheral devices, those are the electromagnetic devices, or we can say like electromechanical devices. But when we go with the processor or the CPU, you can say this is exactly the electronic component there. So there lies a difference between electromagnetic and electromechanical and the purely electronic device, that is nothing but the processor. And then when we go with data codes and formats, the codes and formats which the I/O devices use and the codes and formats which the CPU uses, it is entirely different kind of thing. Like when we take like the codes, the data codes which the processor will use is nothing but it may be using the word format, but it is not like I/O should also follow the word format of the same size. Then we say like data transfer rates. Data transfer rate of the processor is very high and the data transfer rate of the I/O devices is very slow. So there lies a difference between the data transfer rates between the CPU and the I/O devices. And like operational modes, what operational modes the CPU is going to be operating and the peripheral devices are operating, that is also going to be the different. Why? Because peripherals are electromagnetic or electromechanical, but the CPU is the purely electronic component there. So in order to resolve these 4 major differences and to maintain the synchronization, here we are including a special hardware component called the interface component. And here this particular interface component we are going to be using, that is going to be supervising and synchronizing all the input and output transfers. And here in the input output interface, we are going to be studying about 4 important topics. Those are like, the first one we will be saying like I/O bus and the interface module, and the next one we will be saying I/O versus memory bus, and the third one we will be saying isolated versus memory mapped I/O, and fourth one we will be saying it as an example of I/O interface. Let us go and discuss with each and every one. Like first let us go with I/O bus and the interface module. When we go with I/O bus and the interface module, the particular diagram here represents the connection of the processor with different peripheral devices. So you can see like we have the processor, that is nothing but the CPU, which is connected to the different IO devices, like the first one keyboard and the display terminal, second one printer, third one magnetic disk, and fourth one magnetic tape. These are all the IO devices which were connected to the processor. And you can see in the respective figure, like each and every IO device is connected with an interface module. And here you can see like each and every device have the interface module, and here processor and the different IO devices are connected using the IO bus. And when we take the IO bus, it consists of three types of buses. That is, one we will be saying it as an data bus, second one we will be saying it as an address bus, and third one we will be saying it as a control bus. And first, when we go with the data bus, data lines, we say like the processor and the peripheral devices communicate to each other through the data bus. They transmit the data over the data bus. And then we have the second type, that is address lines. The address of the particular peripheral device will be communicated through the address lines. Each and every peripheral will have their own address, and processor will be communicating with each and every IO device through its address. That address the processor will be placing over the address bus. And then we have control lines, and control lines is especially used for transmitting the control information, like example, whether it is going to be performing read operation or whether it is going to be performing the write operation. That kind of information also will be sent to the control lines. So if we take the IO bus, it consists of address lines, data lines, and the control lines. A combination of these lines will be present in the IO bus, which is used for connecting the processor and the IO devices there. And how does exactly the processor communicates with the IO devices? Here inside the interface, actually we will be having each and every interface will have a decoder circuit. And here processor, whenever it wants to communicate with the any of the IO devices, processor will place its IO device address over the address lines, and the decoding circuits which were present in interface of each peripheral device, they will decode that address. And all the interface decoders will decode the address information which is placed on the address lines. But here, whichever the address matches with the device address, that interface will activate the path for that respective device. As an example, let us consider like processor wants to communicate with the printer. Printer will have an address, and processor places the address of the printer over the address lines. Then all the interfaces which is attached to the keyboard and display terminal and printer interface attached to the magnetic discs and magnetic tapes, every interface decoding circuit will decode. But when we go with the first one, when the first interface decodes, it will not find its address. So it will not activate the path with the keyboard and the display terminal. Then coming to the printer, it finds it match with the address. So it activates this respective path, so that it will communicate with the printer. In the same way, the decoding circuit which is present in the interface of the magnetic disk also decodes, but it will not find the address of the magnetic disk. In the same way, the interface which is the decoding circuit which is present in the fourth interface also decodes the address, but it will not find match with the magnetic tape. So it will not activate the path. Only the interface which is attached to the printer, that finds matching with its address as processor wants to communicate with the printer, and it will activate that respective path. And here goes the explanation, like each peripheral device has associated with an interface unit, and as I have already told, we are going to have like 3 types of buses there, and address control receive from the IO bus and interprets them for the peripheral, and it is going to be providing signals for the peripheral controller, and synchronization of the data flow and supervises the transfer of information between the different peripherals and the processor. And here as an example, I have told when we take the control information as an example, when we take printer as an example, printer controller controls the paper motion, paper timing, and selection of the printing characters there. And controller, when we go with the control kind of information, we say like processor will be placing the control information over the control lines, and that control information usually we will be specifying it as a function code. And here when we go with saying as a function code, it specifies IO command. And there are like different types of IO commands. We say like we have 4 types of IO commands, and IO commands are the ones that instruct the CPU to the interface, instruct either the CPU to the IO interface or devices to perform a certain operation, a specific, more specific operation. And coming to the different kinds of IO commands, we have control command, we have like status command, and we have data output command, and we have data input command. Coming to the first one, control command. Control command is especially used to activate the particular peripheral device. It may be any of the peripheral device which is attached to the processor. For activating purpose, it will be using the control command, and it also informs it what it needs to do. And coming to the next one, status command, it is especially used to check the status of the IO devices. What is the status? Whether the peripheral device is ready to accept the data or it had completed the data transfer, its status will be known by the status command. And we have something called data output command, and we say like that particular data output command, it is going to be causing the interface to respond by transferring the data from bus onto one of the registers. In the same way, we have something called input command, where we say like exactly the reverse of the output command, where the particular data will be transmitted from interface registers onto the bus. And here especially using the status commands, the processor will be checking the status of the different peripheral devices, and it will find out whether any issues will occur with the data transfer or not. So after placing the address, the processor will be placing the data over the data lines, and it will send the control information. When it is an control information, it may be the control command, it may be the status command, it may be the input command or output command, depending upon what kind of peripheral it is going to be communicating with. And the second thing which we are going to be discussing is IO versus memory bus. When we go with IO versus memory bus, here processor should communicate with the memory, and processor should also communicate with the IO devices. We know already like the processor will be communicating with the IO devices through the IO bus. In the same way, we have the memory bus, which is especially meant for communicating the processor with the memory module there. Then there are like 3 different ways how processor will communicate with the CPU communicates with the memory and the IO devices. What are the 3 ways here are? The first method is like we say it uses 2 separate buses, one for memory and the other for the IO. Means it uses 2 separate buses. CPU for communicating with memory, it uses memory bus, and for communicating with the IO devices, it uses IO bus. And the next option is like one common bus for both memory and IO, but having the separate control lines for each. In a sense, like CPU will use one set of lines for communicating with the memory and the IO, but different control lines. Control lines for the memory is going to be the different one, and control lines for the IO is going to be the different one. And the third option is using one set of common bus for memory and IO along with the common control lines. So these are the three ways how the processor can communicate with the memory and the IO devices. As I have told, the first option is using the separate memory bus and separate IO bus for communicating with the memory and the IO. Second one, using the same set of address lines and data lines to communicate with the memory and the IO, but using separate control lines. And the third one is like using same set of lines with address, data and control lines for the communication with the memory and IO. Let us go with the third one, where we are going to be saying like isolated versus memory mapped IO. In this, we are going to be discussing about what is meant by isolated and memory mapped IO. And we already know like the processor or the CPU is going to be communicating with the memory and the IO by using the, if it wants to communicate with the memory, it uses memory bus. If it wants to communicate with the IO, it uses IO bus. Then here, for communicating with the memory, it needs to send separate control signals. In the same way, if the processor wants to communicate with the IO, it needs to send separate read-write signals. And also instructions are going to be the different one. And when we especially go with isolated way of IO communication, here we are going to be saying like isolated means separate. So CPU will be communicating separately with the memory and separately with the IO devices. For communicating with the memory, it will enable the memory read and write signals, and it uses the memory instructions. When we go with the CPU communicating with the IO device, it will enable IO read and IO write signals, and it will use a separate IO instructions for communication with the IO. So you can see like we use like distinct memory instructions and distinct input-output instructions for communicating the processor communicating with the input and output devices. And here we are going to be saying like one more thing called memory mapped IO. When we go with memory mapped IO, here it is going to be using single address space. Processor needs to communicate with memory and processor needs to communicate with the IO devices. Here it will consider for both the things, it will consider single address space, and it uses single read-write signals for communicating. Means it will enable single read-write signals. It won't use different memory read-write signals, or it won't use separate IO read-write signals for the communication. So here you can see when we go with the isolated, CPU has distinct input and output instructions, and we say like it enables different IO read and IO write control lines. Even when it wants to communicate with the memory also, it enables like different memory read-write signals. But when we come to the memory mapped IO, it is going to be using the same address space. It uses same address space for both memory and the IO. And here we are going to be saying like a memory mapped. It is not the isolated one. So it uses only one set of read-write signals. So we do not distinguish between the memory and the IO addresses. Why? Because it is going to be treating the same, the processor will be treating the same IO and the memory as the same, and it uses a single address space there. So isolated means separate, memory mapped IO means it is going to be considering it as a single one, where it uses single read-write signals and single set of instructions for communicating with the memory and the IO. And let us go with the fourth one, that is nothing but example of IO interface. When we go with the IO interface, example of IO interface, this particular diagram represents the circuit which is present inside the interface. Actually, here we have seen the diagram that shows like interface module is attached to each and every device. We can see each and every device is associated with the interface module. What circuit that lies in the interface circuit? Here we are going to be studying in the example of IO interface. When we take the example of IO interface, here we have like bus buffers. You can see in the figure we have bus buffers, and CPU will be communicating with this particular bidirectional data bus. CPU, we should have the connection between CPU and different IO devices. So CPU is going to be communicating with different IO devices using bidirectional data bus, and whenever it wants to send the data, it will store that data in the bus buffers. Then we have something called timing and control circuit. Timing and control circuit inputs are like CS, RS0, RS1, read and write. And here CS represents a chip select. In the sense, whenever this chip select is enabled, that interface will be in the working state. If the chip select is disabled, then that particular interface will not work. So chip select should be enabled in order to work and respective interface module. Then we have something called RS0 and RS1. These are like register selection inputs. Register selection, two inputs we have here, and depending upon the binary values which were placed over those particular register select values, respective registers will be selected. In the right portion of the diagram, you are seeing like port A register, port B register, control register and status register. These are like different registers through which the CPU can communicate with the different IO devices. So CPU is sending data to which register? That depends upon the inputs of the register select for RS0 and RS1. Then we have another two inputs like IO read and IO write. Depending upon what operation it is going to be doing. If it is going to be performing IO read operation, then that particular IO read line will be enabled. If the CPU wants to perform IO write operation, then IO write will be enabled. So you can see through the bidirectional data bus at the bottom, you can see it is connected to the CPU. And towards the right side, you can see it is connected to the IO devices. And here we have like four registers: port A register, port B register, control register and status register. Port A register and port B register are especially used for storing the data. Data may be coming from the input devices like keyboard, mouse, and data needs to be sent to the output devices like monitors or printers. So this port A and port B will be used for storing the data. Usually port A register will be used for storing the data which comes from the input devices, and port B register will be usually used for storing the data which needs to be sent to the output devices. And we have here something called control register. Control register is used for storing the control information. Control information may be any of the functional code information like control command, or it may be the status command, or it may be the output command, or it may be the input command. That particular control information will be stored in the control register. And then we have something called status register. Status register holds the status information. That is, while transmitting the data from processor to the I/O devices or from I/O devices to the processor, here transmission needs to be done. When transmission is going to be done, here sometimes transmission errors may occur. That particular transmission errors will be recorded in the status register. And one example of that we can say that parity errors can be recorded using the status register. So here you can say like we have bus buffers for temporarily storing the data, and we have the timing and control circuit which have the inputs of chip select, register select, I/O read and I/O write. Then we have port registers, port A and port B registers for storing the data, control register for controlling the information, and status register for storing the transmission errors information, we can say. And here then how does the processor will be knowing which register it is going to be selecting for sending the data? That particular thing is going to be depending upon the values which we are going to be supplying to the timing and control circuit. Like as we already know, timing and control circuit have different inputs like chip select, RS1 and RS0. So here, depending upon the particular values of CS, RS1 and RS0, that particular register will be selected for transmitting the data. Like, let us consider different examples here in the table. If the chip select value equal to 0, if the chip select value equal to 0, the interface will not be in the working condition. If the chip select is equal to 1, then only we can say like it is in the working condition. So we can say like RS1 and RS0 we are not going to mention. So you can see like representing it with X. And as the interface is not in the working condition, we say like data bus is in high impedance state. High impedance state in the sense it acts like an open circuit. The interface will not be in working condition and it won't transmit any kind of data there. And coming to the next second row, here we can see CS is equal to 1 and RS1 equal to 0 and RS0 equal to 0. Then it selects the port register for port A register for transmitting the data. Maybe the data may be coming from the input device, and from the input device it collects the data and it will transmit to the registers which were present in the processor. And coming to the next combination, CS equal to, coming to the next combination, CS value equal to 1 and RS1 value equal to 0 and RS0 value equal to 1. Then it selects port B as the data register for the transmission. So that let us assume like the processor had completed some particular computation and it wants to put the data onto the any of the output device. Then it transfers the data through the bidirectional data bus from there to the bus buffers and from there to the port B register, so that it will put upon to any of the output devices there. So it will select the port B register. Coming to the next combination, CS equal to 1 and RS1 equal to 1 and RS0 equal to 0. Then it will select the control register for storing the control information, any kind of control information that may be the control command, or it may be the status command, or we can say like it may be read write operations specifying. So it will select the control register for storing the control information there. And coming to the next operation, we have like CS equal to 1, RS1 equal to 1 and RS0 equal to 1, where it selects a status register for storing the status information, like if any transmission errors are there, recording those particular transmission errors will be done by using the status registers. So processor and the IO devices communicates with each other through only the interface there. And here we are going to be saying like already we know we have different registers, port A, port B, which are going to be the data registers, and then we have like control register that will store the control information, like what kind of information it needs to send, and we have something called the status register, which stores the status information. And here whenever we say like read operation is going to be performing, we say like the data will be sent to the processor. The data read operation is nothing but sending the data to the CPU. Write operation is nothing but transmitting the data from the CPU. So here we specify either read operation or the write operation there. And here you can see the explanation like consists of two data registers and called ports. We can have the control registers, status registers. We have bus buffers, timing and control circuits, which the explanation we have already done through. And we have chip select, register selects, and read write for the timing and control circuit. 4 registers are going to be communicating directly with the IO devices which were attached to the interface. And as I have told, we can say like when a command is going to be passed to the IO device by sending a particular word to the appropriate interface register, it stores depending upon like whether it is an data, it will be stored in any of the port A or port B registers, and if it is like control information, it will be stored in the control register, and if it is the status information, it will be stored in the status register. So the control register is going to be receiving control information from the CPU by loading the appropriate bits into the control register, and here the interface and the IO device which is attached, it can be placed in a lot number of variety of operating modes, and here whatever the interface registers we are communicating, it will be always through the bidirectional data bus. As you have already seen in this respective figure, always the communication will happen through the bidirectional data bus through which it is connected to the CPU here, and through here it is connected to the IO devices. And here you can see like the explanation of the table which I have told. Whenever the chip select value is equal to 0, the entire circuit will be in the high impedance state, and whenever the chip select value is equal to 1, and depending upon different combination of RS1 and RS0 values, that respective register will be selected for transmitting the information there. So you can see like we have 2 input select, one for 4 registers in the interface as specified in the table which we have already seen, and the contents of the selector register will be transferred to the CPU via the data bus, the bidirectional data bus, when an IO read is going to be enabled. In the same way, it transfers the binary information into the selected register via the data bus when it is an IO write input is going to be enabled. So it depends upon it is going to be performing either the IO read operation or whether it is going to be performing the IO write operation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.